Here I've brought up the schematic for the battery refresher, and I'll explain how it works, hopefully briefly. So what we can see is that the battery to be refreshed is also powering the whole system. That's why you'll see only 2 leads coming out of the different builds that I've made, and this is not what I've made. This is, well, I found this online, so I don't know if it's from the original site or somebody else who built it, but the schematic is the same. Okay, so this part only serves to have a visual indicator with this LED that the system is working. Okay, and whenever the battery is being refreshed, then you have a short flash, and you can see that it's working. It's very useful because otherwise you have to hook up the scope and everything. It's a pain in the butt. All right, and here's how it works. So we'll concentrate on this area, and once you understand, all you have to do essentially, this is correctly drawn in. The base is not connected, and the emitter is towards the positive side. And here's how this acts. This acts essentially as a large Zener diode, and with some hysteresis, I think, because otherwise it'd be, well, a little bit different, but nonetheless, this typically switches at 11.5 to 12 volts, typically 11.5 to 11.8 volts. So when you connect this, the battery is charging this capacitor via this resistor. Okay, and once this capacitor reaches 11.5 or 12 volts, depending on the breakdown of this configuration here, then this thing becomes conducting, and when this conducts, it switches on these 2 transistors. Now this transistor, as I said, is only designed or put in to activate this LED. This transistor, though, it's more beefy, shorts out the battery, positive and negative, minus the diode drop-off voltage, for a brief moment until this capacitor goes below this breakdown voltage. And that's why I said there's a hysteresis, because it has to go lower than the actual breakdown voltage for this thing to stop conducting. Okay, now this has to do with the PN and NP junctions in silicon transistors, and I'm not going to go into that. I'm not very familiar with the intrinsics. I just know the principles of operation. Okay, so you can replace this schematically with a Zener diode, and I don't know if a Zener diode has a breakdown voltage, has a hysteresis, but it might not work with a Zener diode, but it does work with this with a transistor, which is interesting. Okay, so that's all you have to do to understand. The other cool thing about this schematic, this circuit, is that you cannot run down the battery down to 6 volts or 5 volts, because intrinsically, once the battery voltage goes below the breakdown voltage of this transistor, it stops acting, it stops functioning. So this capacitor will just charge, let's say, to 10.8 volt or 11.4, but this will break down only at 11.5. Okay, so all you have is a very small leakage current in this capacitor, which is in the probably less than a milliamp, so it will not run down your battery like other circuits may. Okay, so that's why I think this circuit is very cool, and I use this circuit on all my batteries that I've finished rejuvenating. And while I've put in ads to sell the batteries, what I do is I hook up one of these, and then they stay fresh, and you know, I just know that they're not gonna sulfate while they're sitting on a shelf for a couple of weeks, sometimes a couple of months.